Introducing the Bayware Service Graph. Why do you program a computer with declarative code but configure networks? What if DevOps could avoid all the configuration by using the original intent, the dataset represented in a UML diagram, as the only declarative input for creating secure connectivity anywhere, everywhere, and whenever they deploy? What if all the networking services automatically generated from this declaration? Very similar to how computers work. Well, then DevOps would only really need to know two things: the UML diagram of their particular application, as well as where do they want to deploy. Let's start with how Bayware realizes the big idea of starting with the UML diagram as the only input. We call this input the service graph. As you can see, we have this getaway application UML diagram, and what we're going to be working on today is creating this service graph of this getaway application. And the best way to explain the service graph is to build one. Let's take a little closer look at the UML diagram for the getaway application. We can see it's composed of 5 different services. We have the HTTP proxy, getaway service, weather gateway, news gateway, and places gateway. So essentially, a proxy with the core business logic front end and 3 APIs. Very straightforward. Not too much is going on here. But what's really important to remember is we get to declare which services can communicate to which endpoints. And that's very, very critical to bear in mind as we explore building out our own service graph here, right? So where do we start? Let's start within the orchestrator. First steps would be to add a domain. When you add your domain, you would fill this in correspondence with your application. I've already done this step previously, so I already have this getaway domain name, which, again, it's just called getaway application. The domain name is just a namespace for my application, right? So next, I'm going to name the microservices that make up my application. I don't have to tell Bayware whether or not the service is a virtual machine or in a container. It doesn't really matter. What does matter, however, is knowing the unique name. And if we take a quick look again at the UML diagram, our application, these service endpoints already have very, very nice, unique names. Weather gateway, places gateway, news gateway, getaway service, HTTP proxy. So you definitely get the gist there. So let's go ahead and make these services. Let's see what that's about. To do this, we're simply just going to begin with just the outline of our particular application. Again, I'm stepping through HTTP proxy. That's what we're currently making, and then we'll make the rest, right? So the service name, try to keep it, A, unique, B, in accordance with your application. As far as the description, it needs to make sense for your organization. So I wouldn't put foo. I would do something a little bit more descriptive. For today, I'm going to say getaway proxy. Right? Pretty straightforward. Everyone understands that. And for the domain, it's going to be for the getaway application domain that we previously created, right? And there we go. We have our first service. I'm going to go ahead and build out the rest of these. Next we'll do the getaway service. And again, the description, try to keep it in accordance with your application for it to make sense. This way, anybody that is in your organization and is using Bayware, they'll see this description. Hey, that makes sense. Okay, this is the business logic. The getaway service makes sense, right? All right, we've made all of the services that compose our application. Let's go ahead and take a look at the service graph, and not much going on. There's not much. It doesn't look anything like the picture. It slightly does, but not so much. So what's missing? Well, we need to make contracts, and we need to assign roles. What does this mean? What does this mean? Contracts are just the connections from each service endpoint, right? So let's start with the connection from the web UI to the main business logic, right? All I have to do is choose a contract template appropriate to a multi-VPC application, give it a name, and assign it to my application domain, and then choose which application microservice is playing which role in the contract. So we'll get into each one of those items as we're going along here. So for the contracts, we just simply come into contracts, click add a contract. Now, again, it's very, very similar to services where unique name, description, domain obviously we know is going to be getaway, and then the template, we'll get into that. So I'll first start with the front end. Right? In the description, we'll just say getaway front end. Right? Domain will be getaway, and then the template. Remember, we want to choose a contract template appropriate to a multi-VPC application. What does that mean exactly? And why out of all the templates available did I choose this particular one, this Anycast cross all VPCs? This is a really good starting point. Primarily because it'll effectively let your services communicate with the same or very similar instances rather in a slightly different VPC. So if you were to deploy this to, say, AWS first, and then you wanted to lift and shift it into Azure or GCP, you simply could do that very, very easily, and then and we can also get into it where you can set costs and limits and force route your traffic the way that you see fit. So I'll go ahead and save that. And while we're at it, let's go ahead and build out the rest of the contracts. Really, it was just the front end and the 3 APIs. So I'm going to go ahead and knock those out really quick, and then we'll come back and talk a little bit more about assigning the specific roles and what exactly that means. All right, I finished creating all the contracts. Let's quickly look at the service graph now. Again, we don't have any roles assigned, so nothing's wired up, so to say. And for reference, we can see the service graph in this current state. And if we go and look at the end result, what we're trying to build, we're close, just not quite there yet. So now we need to add roles, right? There's a couple different ways we can do this. We can click on this service endpoint and click on the service name, right? That's one way to get in there. Another way, we can just as well, go into services, click on a service name, and get there just the same. But for today, we'll click on the service name here, and let's start here, right? We'll say the front end originator, and remember that per our specs, we need to choose which application microservice is playing which role in the contract, right? So an application engineer should know this. Maybe somebody else, per your organization would know this. Which endpoints need to be wired up and be able to communicate to other endpoints and services, right? Real quick, if we look at this service graph, or even just the UML diagram, we can see client. They're going to send a request. It'll go through the internet, gets routed through this proxy, hits this business logic, and from there, this may route it to, let's say, I wanted to see the weather in San Francisco. Obviously, the weather gateway is going to respond to that, in return the query. So it's something to keep in mind as we're electing the contract role, whether or not it's originator or responder. And for a real keen eye, you might say, well, it's both, right? And that's not invalid. That's absolutely valid, and we'll see how we handle that here in just a moment, right? So let's actually explore that right now. Let's get in the getaway service, because this is our main business logic. So this is going to be both, right? But it's on a per contract, right? So for the particular getaway service, the front end would be the responder, right? I'll say that again while we're looking at the UML diagram. The front end will be the responder, right? Makes sense, okay? We have that, but we also have the 3 APIs. We have weather, news, and places. So from the perspective of not only the UML diagram, but from the getaway service, the business logic, for those 3 APIs, how is the connection made there? What kind of role do we need to assign there? And for that, those would be originators. Okay? Pretty straightforward. So I'll go ahead and add those now. All right. Now we just need to take care of the remaining. We can see, roles assigned 0, so let's go ahead and take care of weather, news, and places. All right, now we've assigned these roles. So now we can take a look at the service graph, and that's looking a lot better. It looks very similar to what we're trying to create here, this completed service graph of this UML diagram. Very, very, very straightforward. And now that we have this completed UML diagram, that's a big bulk of Bayware right here. Is once you have this, all you need to know is what do you want to deploy and where do you want to deploy it. this service graph. This is what I want to deploy. Where do I want to deploy it? That's for me to figure out. I may want this just in AWS. I may want this in a private data center. Doesn't really matter, right? The service graph declaration is all I need to define the policy. And again, all I need to do now is to deploy Bayware components and my application, the getaway application, into my target environments, VPC, right? So, Bayware has built a very powerful technology that is simple and easy to use. You can configure other solutions extensively and eventually get them to produce a service graph when you're done. However, Bayware uses the service graph you already have as input. This service graph is our input, right? And using this simple declarative input, there's no more complex configurations. You don't have to go and learn multiple APIs just to try to deploy or make an update, or do a rolling hot fix, so to say. Don't have to worry about that. Or if this is your first deployment ever, your first time going to production, it's very straightforward. I don't have to learn a lot. And a very beautiful thing about this is Bayware automatically creates highly secure, highly efficient interconnections between all your application microservices, regardless of how you package them, and no matter where you deploy them or how often you want to change your deployment.